Well, I'm going to start again. I am so sorry. I'm going to start again. I am so sorry. You guys are too polite. I was on mute. So welcome back again to our Wild and Fire seminar series. We have a distinguished speaker with us today that I'm so excited to introduce. This series, as is usual, is we are gratefully appreciative for the sponsorship and support of the Bill Lane Center for the American West, the Woods Institute for the Environment, as well as Stanford Sustainability Data Science. And as I was saying on mute, for those of you interested in the wildfire space, I also wear another hat during spring quarter, directing the Wild and Fire Challenge event. And we are looking for both intellectual and financial contributors to make that class and event possible. So if you are interested and you're here live or hearing the recording, please contact me. We'd love to talk about how you might be involved in that. But without further ado, since I'm now on the mic, I'd like to introduce today's speaker, Mark Bathrick. He is the former director of the U.S. Department of Interior's Office of Aviation Services. As director, Mark was instrumental in effecting the greatest modernization of wild and fire firefighting aircraft in the last 30 years. For example, he authored the test plan and led an interagency team that assessed and approved the very large air tanker for widespread federal aerial firefighting operations. He was also the architect of the Department of Interior's award-winning Drones for Good program, where he led the development and fielding of multiple new drone applications that revolutionized wildland firefighting, search and rescue, and science and climate change missions. He was the recipient of the 2017 Commercial Drone Alliance Industry Heroes Award, was selected by the Commercial UAV News as the top 7 drone visionary in 2018, and received the DroneResponders.org Public Safety Drone Leadership Award in 2022. Prior to his work with the Department of Interior, Mark completed a distinguished career as a Navy career-based combat fighter pilot, experimental test pilot, and Top Gun graduate, for those of you who are huge fans like I am of both the Navy and the Top Gun enterprise. We can chat about that maybe at the end. Mark also holds a Bachelor's of Science degree in Aerospace Engineering from the U.S. Naval Academy, an MBA from Boise State University. As president currently of Bathrick Aviation Consulting, Mark enables industry and government teams to achieve higher performance by leveraging over 40 years of diverse experience in aviation program development, management, and operations. I'm sorry I read that really fast. I actually skipped over a lot of amazing things Mark has done in his career, but we want to hear from him. You don't want to hear from me. We want to hear from him. And Mark, thank you so much for your time today. A big shout out to Bill, who connected me with you. And I know a lot of people are interested in what you have to say today. So thank you for joining us, and I will turn over the screen sharing to you.
All right. Thank you, Bill. And that just means I'm old. I have a lot of stuff in my head past here. Let me get us on the screen. Here we go. All right. Everybody can see that, I hope?
Yes.
Perfect. All right. Well, thank you for the very kind introduction. And given all that Stanford has done and continues to do for this important national issue, I'm thrilled to be here. And a shout out to my friend Bill Van Delsum for connecting us as well. So flight plan for today. I have some material I'd like to go over, and then I really want to get into the meat of it, is to have some conversations, discussion, and your difficult and pointed questions in this important area. So I always find it helpful, and last week was no different with Bill Clerico, my colleague, to understand speakers' why. You know, what has propelled them to become an advocate, very passionate about a particular issue. And my why goes back now 40 years. And as a fledgling naval aviator, I learned that my role was a support role. I was supporting ground personnel at sea and on the ground in their mission, and that was my role. And I also learned that as a Top Gun trained naval aviator, that to do that, it was important that we be able to fly in all conditions, day or night, because in doing that, we are able to not only support our ground and sea personnel directly, but also indirectly, and perhaps most importantly, do that while the enemy, the adversary, was at their weakest, at their most vulnerable. Later, as a test pilot, I was exposed to some amazing technologies that promised to greatly enhance the effectiveness of our missions, improve the safety of our air crews and those that we supported on the ground. I also experienced the frustration of the federal acquisition system and moving from technological concept to fielded capability. And conversely, I witnessed the amazing pace at which the private sector could move technologies. I was there back in the day when GPS was brand new, and being an acknowledged disruptor, I often incorporated technologies like that in my own aircraft to enhance our ability to support the ground and sea forces, even if the Navy hadn't officially approved it at that point. The Navy also provided me with great opportunities to lead several large organizations, critical learning there in change management, particularly in the government sector, which is, I would say, some of the more challenging environments to do change management. And my last Navy position, my command tour as a base commander, was particularly influential in my second career. I was in charge of a 7,000-acre Navy base, which had significant forested and grassland areas. It was also the site of some one-of-a-kind Department of Defense infrastructure. And so we didn't want that to burn up. And we had a very aggressive, very robust fuels management program and wildfire mitigation program. We also supported a number of interagency drone development programs, and coupled with my ongoing relationship with drones and optionally piloted aircraft that began when I became a test pilot, that was very influential in where I went after I retired from the Navy. So retiring from the Navy, I was brought on board on the civilian side with the Department of the Interior as a senior executive with the Office of Aviation Services. And for those who may be a little bit unfamiliar with DOI, the single largest land steward in the United States, particularly out west, huge swaths of land, over 500 million acres total in the United States, which puts it about 1 in every 5 acres is stewarded by that agency. And they have a large responsibility in addition to their partner agency, U.S. Department of Agriculture, in wildland fire management. As the director of OAS was known, I supported all 9 bureaus and all of their missions, including wildland fire, which was the largest single mission that we supported. And so when I arrived at DOI, several things caught my attention as I reflected on my previous career. First was the funding. As I like to tell people, the entire appropriation for the Department of the Interior is not enough to buy one of the new modern aircraft carriers that I used to land on. And even though there are billions spent on wildland fire operations, they also are spending very little to no funding for technology improvement, research and development. The aerial support that I was tasked to provide the agencies was not in the way that I had been brought up as an aviator. Having gotten up in the middle of the night many times to conduct military flight operations, I was shocked that the aerial firefighting was confined to the daytime in clear air conditions, with launches rarely occurring before 10:30 in the morning, sometimes not until afternoon. I was also surprised with the ground philosophy in terms of aviation support. It was generally accepted that aerial support was important when there were firefighters on the ground, but it wasn't really needed if the firefighters weren't there on the ground. So these facts, coupled with my being a disruptor and a believer in the ISO 9001 quality standards and committed to relevant, measurable, and externally audited processes and outcomes, And later my role as an angel investor really compelled me to not only be focused on this, but many other aspects of wildland fire where I think we can make great improvements. So wildland fire, as we all know, is a natural and necessary part of our ecosystem. However, decades of human-induced imbalances in how we've addressed wildland fire has resulted in it becoming an adversary that has increasingly inflicted larger and more frequent costs and losses. As you can see here by the slide, by every measure, wildfires have gotten worse, burning more acres, extending their threat to the point where wildfire season, as we used to know it, has now become the wildfire year, encompassing all 12 months. And it's draining us of significantly larger amounts of government funding to fight it, and really costing us hundreds of billions of dollars in economic losses and health losses, where it's adversely impacting the life expectancy, not only of the folks that are directly exposed, but also those throughout the country. As we've seen this year alone and previous years, the smoke has enveloped, I live on the East Coast now, enveloped us for days. And as we like to say, smoke knows no borders. So again, what is a natural and in many cases beneficial thing is now gotten out of hand, and we need to take extreme measures to address it. In order to effectively address this wildfire management challenge and specifically understand the role and importance of aerial firefighting in degraded visual environments, I want to take a minute to just kind of review the components of the wildland fire system of systems. First, there are three widely accepted phases to wildland fire. There's the pre-fire phase, the active fire, and the post-fire. Within those phases are what I call the 7 links in the wildfire chain. These interconnected links represent broad categories of functions and activities that occur within each of the links. As with the 3 phases, neglect or enhancing performance in any one of the links has a relevant impact on the following link in the chain and the overall system of system performance. Supporting each of these links in the overall wildfire system of systems is very data intensive, and increasingly it involves using technology on the far edge, near edge, and cloud in terms of collection, processing, networking, and dissemination functions. So when we talk about degraded visual environments, it's really the rapid initial attack. That initial attack on the fires is an ignition has been determined and detected. The extended attack for those evolved fires, and then in the beginning phases of the recovery, when you're still doing the mop-up. Those are the 3 areas where the degraded visual environments have the greatest impact. Now, one of the things I need to cover on wildland fire, in my experience, one of the things many people and companies don't understand or fully appreciate is that it's firefighters on the ground. That's how wildfires are contained and extinguished. And I say that because, again, aviation is support. The other surprising thing is that firefighters don't necessarily recognize that aviation can also support when they're not directly on the fire line. And going back to the firefighters being the ones that contain this shouldn't be a surprise, because if anyone who's been a Boy Scout or Girl Scout or has even gone camping knows that water alone will not put out your campfire. It takes a combination of that suppressant along with the physical action of that stick you were taught to use to stir the coals, expose those hidden pockets of heat and fire, so that they can be deprived of either fuel or water can be used to then put them out. Likewise, aviation provides that critical support to the fire. It can also provide that support even when the stick may not be there. Pouring enough water on the fire will not put it out completely, but it sure make the job for the stick a lot easier when that stick finally shows up. So let's talk a little bit about the history, the roles, and the current state of aerial firefighting. 1930, someone who's ingenious rolled a barrel of water out of a Ford Trimotor onto a forest fire. And that was actually the first application. Since then, firefighting from the air has expanded from direct drops of suppressant water to delivering chemical retardants to slow the spread of the fire, contain it, performing critical personnel, supply and movement missions, and even emergency extraction of injured firefighters. There's some things, however, that have unfortunately not changed much over the past 93 years. As in 1930, aerial firefighting today is predominantly a day clear air operation that's unable to support firefighters or the communities that they protect during the DVE periods we'll be discussing here in a bit. Also, as in 1930, the active suppression outcome effectiveness measurement data is not taken during the fire. So there isn't this outcome measurement and how we're doing and how we might be able to do better that we could go back to and maybe update our models in the future. So let's talk about the definitions. DVE is actually a defined term, and it's an aviation issue that affects all types of traditional crewed aviation applications. It's about those conditions where the situational awareness and/or the aircraft control cannot be maintained because of those degraded visual conditions. In wildland fire, there are two periods. There's a day period, which most folks don't initially think about. But what happens there is the wildfire, particularly in those evolved fires, it cools and settles to the ground at night, and it remains there until the heat of the next day or the winds dissipate it. And then at night, of course, there's darkness, but also there's smoke that can be a contributing factor in that degraded visual environment. All right, so we've identified what DVEs are, what the links are in the chain to affect the operations for the initial and the extended attack. Let's discuss the impacts in a little bit greater depth. I mentioned in the previous slide that during evolved fires, there are two separate DVE periods. The first one's in the morning hours. We have smoke that's cooled as it's risen and dropped to the ground, settles to the ground and obscures visibility, makes it impossible for the aircraft to see the ground and effectively safely carry out the missions. At night, we have dark and smoke. If you look at this and split the day up, we've got these three periods, and the day VMC period being about 8 hours, the other two being about that. We end up with being able to work at about 1/3 of the available day period. Now, imagine if we are now able to work in both of those, we can increase the amount of support by 200% each day to our firefighters and the communities that they're protecting. Not only that, there's another benefit. Generally, the environmental conditions in these two DVE periods represent periods when the winds are diminished, the temperatures are lower, and the relative humidity is higher than it is during the heat of the day, the clear day VMC periods. What's that mean? It means that the fire is more vulnerable to those suppression activities than it would be in the day VMC period. I've talked about the extended attack, also talked about the initial attack. DVEs are not just a problem during extended attack. In 2017, DOI did a study of wildfire ignitions between 2015 and 2017 and found that nearly 20% of those ignitions occurred outside of the traditional firefighting, aerial support firefighting hours. What's that mean is that these fires are starting. We might be able to get some ground forces in there to do something, but traditional aviation has not been able to get in there and help support. Another interesting fact is that 66% of those were discovered between the end of flight operations at midnight, the longest period there of DVE between the night and then the consecutive morning DVE, giving them ample time to grow without that, without being contested by air support. So I want to talk about a couple of personal experiences I had in this area. I was given the opportunity for a lead plane ride along. I was the director of OAS in 2013 on the Beaver Creek fire out of Sun Valley, Idaho. Almost immediately, the fire threatened high-end homes, significant areas of cattle grazing land, power, and transportation infrastructure. When I went for my flight, the fire had grown significantly from its slow start on its way to 115,000 acres it would eventually consume. As a senior executive, my opportunities to get in the cockpit were rare, so I was very excited at this opportunity. While I had a good understanding of aerial firefighting operations as a result of being there for 8 years, I knew that being able to experience it from the air would provide additional valuable insight. Having been accustomed to 0 dark 30 briefings, to be overhead the target at first light, I was ready to go. I was surprised that I didn't have to show up until 9 o'clock, and that was for the overall fire briefing. That was followed by the briefing for the flight at 9:30, coffee on the flight line. We had enough time to go downtown for lunch, and we didn't launch until 1:30. And we didn't launch until 1:30 because we had one of these day DVE periods where we could not see the ground, so it was not safe nor would it have been effective to launch aircraft in support of the ground forces. We finally got out airborne and get out there. We were managing tankers, and later in the afternoon, the winds came up, so that it became unsafe to fly. And so by 5:30 that afternoon, we had to knock it off and send everybody home. What was critical about that was we were dropping a line of retardant along a ridge. To the south of that ridge were a lot of expensive homes and ranches and infrastructure. And with that line not completed, the fire could have gone right through that line as if it had not been there at all. We were fortunate that the weather changed that night and the fire never got to that line. But that emphasized to me the importance of having the ability to support the fire and support those communities during the DVE periods. The second personal experience I had was with a member of my staff. There was a large fire in 2016 in Idaho, just north of where I lived, called the Pioneer Fire. And across our staff, we had several members with deep wildland firefighting experience. During each fire year, particularly when the number of wildfires intensified, staff members with key wildland fire qualifications would be called up to support operations. So not only gave them an opportunity to keep their skills honed while giving back, it also provided them with valuable insight they could apply to the initiatives that we were working on at OAS. The Pioneer Fire was one of those instances. One of our uncrewed aircraft systems staff members, a former smoke jumper who had been involved in our efforts to develop and find solutions for DVEs, was asked to go out on the Pioneer Fire in a safety role, responsible for observing, assessing, possibly influencing the safety environment across the fire. And in that role, he was exposed to a wide range of activities and was pretty much all over the fire. The fire itself turned out to be among the largest in the United States that year, lasting nearly 4 months and burning nearly 190,000 acres. When he returned from a 3-week stint out there, what struck me was when he came to my office, I asked about his experience. He said that there were at least 3 times during the fire that he felt that they had the ability to drop water at night through the morning DVE, they would have been able to likely stop that fire in its tracks, and it wouldn't have grown to the 190,000 acres that it grew to. And that was really impactful, particularly since I lived in Idaho and got to see the extensive damage caused by that fire firsthand. And after those experiences, I couldn't help think, how would we react if our structural firefighters faced similar limitations? Imagine if you woke up in the middle of the night and, my gosh, your house is on fire. You dial 911 and the dispatcher says, I'm sorry, we can't send the fire truck with the water until daytime, and hopefully the smoke is cleared, otherwise it might not be able to come. I mean, that's essentially what we're saying to our firefighters and the communities they protect in our current aviation support for wildland fire, unable to support them in DVEs. We've talked a lot about initial attack and extended attack, but I really want to make sure I do not forget, and I want to emphasize that logistics and emergency extraction are also adversely impacted and are incredibly important to our firefighters. I learned this firsthand when I was focused on the suppression aspect, and one of my firefighter staff members said, "Hey, look, if we don't get food, water, spare parts, gas, we're not out there in the line." And that can often happen because the smoke that I talked about during the day periods can actually last for multiple days, upwards of a week before the weather changes and there's sufficient wind or heat in order to burn this off. And so not only do they need resupply, they also need to move. They move with the fire as they're having success attacking that fire. And if the fire is having the success, then they're moving away from it to stay safe. In either case, that often requires aviation support, given the nature of wildland fire, the remote nature, and being away from traditional transportation infrastructure. And it's a dangerous profession between trees, rocks, equipment, rolling over chainsaws. Firefighters every year suffer injuries that require their immediate extraction. And in most cases, aviation is the quickest way to get them out to the medical attention they require. And if we're unable to fly, that puts them in a very, very difficult situation. So I always ask this of companies that come to talk to me as an angel investor. So what's the potential ROI of solving this? The fact is, no one knows for sure because it's never been studied in any detail. However, we can estimate the potential range of values based on available data. We know that DVs currently prevent aerial firefighting support to ground firefighters in the communities they protect about 16 hours every 24-hour period. We know that DVs generally include atmospheric conditions that enhance the effectiveness of aerial suppression and make the fire more vulnerable to it. We also have lots of historical data on acres burned and suppression cost data from the National Interagency Fire Center. Now, while I can't say for sure what a 200% increase in aerial firefighting coverage and support will absolutely return, what I can tell you from the data we have is that every 5% improvement this brings to reducing the time in the area to contain wildfires would save $143 million and 407,000 acres. And that's based on the 5-year average for those based on the data from the National Interagency Fire Center. And to put the acreage in perspective, that land area is about the size of New York City and LA combined. It would be saved. And certainly $143 million, even at 5% reduction for a 200% improvement in that support is not a small chunk of money by anyone's measure. So let's talk about, so what are some of the opportunities? The one I hear most is night vision devices, or NVDs. And that's a reasonable first whack at it. I had the opportunity when I was in the Navy to fly with NVDs, and they are great for seeing at night. And they've been employed in limited local wildfire agencies like LA County, but it's noted that they have not been widely adopted across federal and state wildland fire programs. And the reason for that is first cost. In 2019, DOI analysis showed that outfitting helicopters with NVD compatible lighting, which is a requirement, attaining and sustaining aircrew NVD qualifications, which are extensive and do require frequent refreshing, can put significant strains on their already limited funding, especially when compared to DoD counterparts. Again, DOI found that it was about $207,000 per helicopter and a crew of 3 just for the outfitting costs. And then the initial qualification, $6,000 per pilot, and then the recurring costs. And then we have the ramp up cost, which, as the wildfire year winds down in the fall and the winter, a lot of those pilots will go off and do other things, and as it ramps up, they need to regain their qualifications. And the longer you're away from NVD flying, the longer those qualification flights take. And then finally, the last thing to remember is that only covers at best half of the DVE periods. The other half is the day DVE period, and NVDs do not work during the day. They only work at night. So what's been done? So the video you're seeing on the screen here is a compilation of 2014 and 2015 tech demos. And that's not a typo. Yes, that's 9 and 8 years ago. We took the KMAX helicopter, which we contract for on wildfire, which have been developed by DoD as a tool for the Marines in Afghanistan, have been used successfully there from 2011 to 2014. And said, could you do this in wildland fire? This first test here is at the New York State UAS Test Center. As you can see, we've dropped water. We're doing a delivery of a vehicle, could be crew to either extract or put in, and then we're doing logistics. And these flights are all being flown from the ground. There's a safety pilot on board with hands off the controls. In 2015, we moved this out to Boise, Idaho to put it in some mission representative environments. You can see it there doing the automated water pickup and then flying to the drop area. Conveniently, there actually was a wildfire north of where we're doing these tests. And you can see the reduced visibility there. We did both the drop for a trailing line as well as the spot drop, and did this multiple times to show what the aircraft could do. And we did 4 resupply loads in some terrain, so not just on flat ground. The thing that really stood out on this demonstration was the difference. What you're looking at is one of the 2 sensors. It's the EO camera, and there's the IR sensor. And if you look in the reservoir to the right, you can see a boat, and out front you can see a white area. That's where we've dropped water before. Now we go back to the EO camera, and you can't see either one of those. And these are the sensors that the helicopter uses for navigation, targeting, and avoidance of other aircraft. And what really struck me as we watched this video was the ability of that to be able to see where we dropped before. And as you can see here, as it stops, we could actually measure that and had that area, and had that been an actual fire, we would likely see if the fire was starting to burn through, we dropped, and we could adjust and drop on that part again. And again, this was done, flown from the ground, mostly by putting in waypoints, but also had controls by the ground pilot in order to sweeten up the drops, which they frankly didn't have to do. So concept of ops, what was our concept of ops that we put with this? Well, the idea was for this KMAX was to retrofit to current contracted helicopters. Most of the helicopters flown on wildfire are contracted. We wanted to base them within the temporary flight restriction and operate them out of there because we had, and we still do, have beyond visual line of sight authority from the FAA within the TFR. Interestingly, we were going to fly those in the traditional piloted configuration during the clear air days. A piloted helicopter can make faster circuits and drop more water in a period of time than you can through the process with the optionally piloted. And at night and during the day DVE, we're going to change to that remotely piloted configuration. And the goodness in this was that the contractor makes more money because they're flying 3 times more than they were before. The current pilots remain employed. They benefit from working for healthier companies, which likely have more money for training. And for the fire side, we had no more additional aircraft to place on the fire, and we could use the current contracts and just add an uncrewed configuration light on them. And then when the fire was over, we put the pilot back in so we didn't have to worry about airspace clearance to go from fire to fire. Now I'm a fixed wing guy by trade, so why rotary wing, not fixed wing aircraft? I believe that there's definitely a future for that, but one of the things we have to understand is the human aspect of it. And I can imagine people in their airline looking out the window and seeing a tanker with no pilot in it going by and having a little bit of concern, as with the people who are living adjacent to the airport, and perhaps the people that are boating on that lake where that scooper without the pilot is coming in. I think that it will be safe, but we have a job to do to prove that and to get the public on board. So that's why we looked at helicopters first. So what are the challenges? We talked about the importance, the opportunities, now the challenges. Might be surprised that technology isn't in the top four. And it rarely is in this area. Really, it comes down to these four things. First is the focus. You've got to remember that for decades, we've been emphasizing quick suppression and traditional methods. And so we have this organizational muscle memory that's what we're focused on. And that's where people are trained. That's where our policies are written. The second one is the structure. The National Wildland Fire Coordinating Group, 99 committees, and most of those are involved in preparing and conducting wildland fire operations. And the recent report to the president by the President's Council of Advisors on Science and Technology pointed out that we don't have that framework that can bring those technologies to bear. So it is that's part of the structure. And the funding, I'd mentioned the reduced funding that DOI and USDA have. That fire also flows to agencies that are responsible for operations and not R&D. And then the culture. There have been decades of industry and others failing to, in my personal opinion, understand, respect, and work with the culture that has thwarted their technology efforts. Every day on the fire line is a day in combat for those folks. And they need to have things that are fully vetted and they've been fully trained on, and it becomes their muscle memory. And we've had some success. Was mentioned in the introduction. There are a lot of good successes out there, and they frankly weren't asked for, but we respected the culture and were able to bring them to the firefighters. So talk about some of the opportunities here. One that I'm most excited about is NASA's Advanced Capabilities for Emergency Response Operations program, the CERO. That program is not only focused on wildland fire, it's addressing that first, but it's also focused on emergency response operations. And it takes into account and really marries up perfectly with the February 2023 report to the president on modernizing wildland firefighting to protect our firefighters. It marries up very nicely with the Bipartisan Infrastructure Law, Inflation Reduction Act, and the Dingle Act of 2019. And it's a very collaborative effort involving industry, philanthropy, and academia, as well as, of course, all of the wildland fire agencies. So I think this is a great opportunity for the future. I'm also excited about several companies that are continue to work in this area. Rotor is one. It's working on remote piloting and advanced fly-by-wire and automation, and doing it in a platform agnostic kit. So you, like we talked about in the KMAX, you could fit it on anything as a retrofit item. Beyond Flight is looking at AI upgrades to existing aircraft, improve drop accuracy, safety, and then looking at the air tanker side of it for 24/7 suppression. RAIN in California is focused on autonomous initial attack and an infrastructure model where these would be stationed around and be able to respond very quickly to detect the ignitions. And Sikorsky has been working for years on a optionally piloted UH-60 and is now partnering with RAIN. So there are companies out there that are working on this. It's very exciting. So some conclusions, summary. Wildland fire is not only natural, but necessary. we have to recognize that for decades, the imbalance has driven us to a point where it's now a global, national, and inherently local threat. I remember my first year in Boise seeing an orange line on the horizon and wondering what that was. And that was a wildfire that was pretty close to my house. And that certainly made an impact on me. It was a very local threat. Wildland firefighters and the communities that they protect, they really do deserve better aerial firefighting support. And it's really time to train and equip them with this technology from this century. As Einstein said, doing the same thing over and over again, sometimes for 93 years, expecting different results is the definition of insanity. And we have to recognize that technology isn't the greatest challenge. We have to work with the firefighting agencies, understand their focus, structure, funding, and cultural challenges that have been part of their history for 150 years. And we need to think and act differently in collaboration with them. So now to the most important part. Questions and discussion, and I just want to thank Dr. Fong again for having me here, for Bill for suggesting it, and thank you for listening.
Well, that's great, Mark, and I'll open the floor to questions. I've learned a ton today. I need to digest what you've spoken, but I really appreciate what you shared today. So I'll open the floor to questions. I have a lot in the back of my head, but I definitely want to turn it over to the audience first. Questions? And if you're too shy, you can put it in chat and I can read it as well. Bill, why don't you go ahead? I see you off mute.
Okay, well, Mark, amazing job, I think. Very impressive. I was just wondering, what do you think an organization like Stanford could do to help?
Well, let me first say, I think Stanford's doing an amazing job. This seminar is part of that, but I've been amazed with all of the research that's going on. I think being a part of the NASA Acero project is incredibly important. I do think, and this applies to everyone, I think we focus a lot on the technology. And as I said, it's the human aspects of it. It's the organizational aspects of it that pose the greatest challenges. And I know that firsthand from the programs that I was able to move forward. Again, it wasn't the tech that was my biggest challenge. It was that. And so universities like Stanford have incredible resources and very smart people who understand these things and how to influence individuals and organizations. And I think that most agencies don't have that expertise.
Cool.
I have another question from the audience. Thank you, Bill. I'll ask one while people are thinking. Mark, I really appreciated just the perspective and what you provided today. And I really, seems like the punchline you said, it's not technology, right? It's structure and I guess historical inertia in one way. And I can say, based on my experience in wildfires of these things the last 6 years I've been involved with, CAL FIRE would say the same thing. They came into our hackathon and said, gosh, we need outside the box thinking. So the question is, you were optimistic. You talked about what, the President's report and infrastructure acts. Where do we stand? I mean, how many years is it going to take so that we are doing 24 hours or 16 hours of aerial firefighting? Do you think we're close, or is this going to take another decade of, holding people's hands and convincing them that this is doable? Or do you think people are convinced and now the ball is starting to roll?
Yeah, thank you for that question, because it reminds me of something I was going to cover on one of the other slides with the KMAX 2014 and 2015 demonstrations. It was in the slide, but I want to emphasize that both of those demonstrations, which cost millions of dollars, were both funded by industry. The government didn't pay a dime for either one of those. And flying a helicopter all the way out from Connecticut to Boise was not cheap. After those two, industry said, okay, government, it's time for you to pony up and put this over the finish line. It was going to be $10 million to finish the integration testing and first field this capability. and again, because of things I talked about with the structure and the way funding is, the firefighting agencies were faced with a very difficult choice. $10 million into a technology that they'd seen, they thought performed very well in the 2 demonstrations, but wasn't yet fully proven in their mind, or $10 million to get new fire engines, maybe contract for a couple of traditional helicopters. And so I think that, you know, the technology was there 9 years ago. I mean, this had flown successfully in Afghanistan. We had dropped twice, you know, 2 different tests. It met all our exit criteria, and the technology is there. It's getting the will and getting the funding. So, you know, in my organization, I used to joke that my R&D budget got doubled every year. So zero the next year, 0 the following year. And so there wasn't this structure to provide dedicated R&D funding to the aviation organization within Interior to conduct the final tests. So I think that, again, addressing those things first and understanding that they exist and they're an issue. And then, again, the last one I can't overemphasize. Firefighters face enormous challenges, and they're some of the most dedicated people I've had the privilege of working with. And they need to understand that every piece of gear that they are using on the fire has been fully vetted, has been fully tested, and they fully trained on that. And I think that's where we need to start from. It's one of the reasons in every briefing I'll ever do on wildfire, I point out that it's firefighters on the ground, not the aviation overhead, that eventually contains and extinguishes that fire. We're just there for support.
Yeah, I mean, I want to follow up, and then we got a question from Joseph on the chat. So where do we go? I mean, I used to, at Stanford, I'm glad we're making some influence, but who do we need to talk to? How do we need to get the word out? You know, it's got to go to Congress, which I know they're in a standstill right now, but, you know, if it's been 8 years, do you see, has progress been made, or it's still just in holding pattern?
You know, great question, and I appreciate the follow-up, because the President's Council on Advisors on Science and Technology, the PCAST, they put out a report this year, February of 2023, and that report is probably one of the best reports I've ever seen on wildland fire, because it was very direct, it was very pointed, very technology oriented, but it also understood the culture piece. And so that report has gone to the President. There are 5 recommendations in there. Again, very tight recommendations. And they tasked the agencies, to include NASA, to work together on DVEs and many other aspects of wildland fire to provide modern equipment for our wildland firefighters. And even in the report, they said that there are aspects of the technology and the organization of wildland fire that are stuck in the last century. So I think that, you know, you don't get much higher than that report. Is, again, I also mentioned the Acero project. Again, involves all of the fire agencies from state to federal. Involves you know, industry and academia. They are developing a technology roadmap that will be used by the agencies and industry to define where we're going in the future, and it will involve some demonstrations. So, you know, I'm hopeful that one of those demonstrations will include some activities in the DVE arena to show how we can support those firefighters during those 16 hours a day that they currently aren't supported.
Great. Well, I guess there's some hope. There's some hope there. So thank you for that update and some optimism I hope we can have. So I'm going to read a question that Joseph had here in the chat. He says, do UAVs have a viable role in ignition detection operations, or in automated ones? Will the FAA ever allow it?
Yeah, so UAVs, drones, UAS, however you want to call them, RPAS, definitely have a role. They have many roles. In fact, we use them today on wildfires, both strategically over the fire to do mapping and hotspot detection, and even tactically with small units to do much of the same. And we also use them for aerial ignition, which is an important role, particularly on on a fire where you're doing burnouts or backburns to reduce the available fuel for the fire. And in that capacity, we can do those burnouts at night, which is the very first time we've ever been able to do that. So there are incredible uses for drones. As I mentioned, within the temporary flight restriction that's often put over larger fires, we have the authorization to fly beyond visual line of sight. And in my experience at DOI, there have been numerous fires where drones were the only thing flying on the fire for multiple days, up to a week. So we see, and, in fact, the optionally piloted helicopter, someone would consider a drone. It's being piloted from the ground, but it can also be autonomous. So again, lots of opportunities. And the FAA has actually been very generous with how they've been treating wildland fire in many cases. So I think it can be used. There's still work to be done. And I know a lot of the companies like Rain are working with the FAA, agencies, NASA, Interior, and Ag are continuing to work with the FAA. And, frankly, we couldn't be as far as we are today had the FAA not been very forward leaning when it came to wildland fire.
Great. Thanks for the insight and thanks for the question. We're at 125, but we can take one or two more questions, I think, as long as Mark's willing.
Sure. And I have my contact information up here. Feel free to email me, and I will get Derek a copy of the slides. I know this is recorded, but happy to share those as well.
Awesome. Awesome. Thank you, Mark. Bill, did you have another comment or question?
Well, I see we have a student or two from the computer science community. So I was going to ask, do you think there's additional advances we might want to make in terms of fusing data across multiple sensor platforms? Or is what we have good enough?
I'll answer the last part first. We're nowhere close to good enough. The other thing that excites me, in addition to the DVE work, is the value and the potential for data on fire. We have so many opportunities and challenges, but so many opportunities to leverage the data that we could collect. As I mentioned, we're not even collecting data because we're not measuring the outcome effectiveness of the drops that we do. There was a study done some years ago, but that study, it was a static study. It didn't provide protocols and processes to continue measuring that. So there are a lot of opportunities, and the ACERO program is looking at those as part of their remit on the technology roadmap. And again, where Stanford, could definitely help along with the other universities and industry.
It's great to hear. Any final question? I'll add one more if we don't have any, but I want to open it up to others if they want any more questions.
I have one question.
Go for it.
Thanks for your presentation, Mark. I think a lot of my questions were already answered, but the one that I do have is, you mentioned that there are some companies out there like Rain that are working on solving this problem, and there's also initiatives in governmental agencies like NASA that I hadn't heard of before. Where do you think that finally the government will adopt a solution from? Do you think it'll be a very collaborative solution with public companies and also initiatives like what's going on in NASA, or do you think that the government usually defaults to internal solutions to these sort of problems?
Yeah, great question. Thank you. I would use some previous experiences. So the drones that we used, continue to use, are commercial drones. The Very Large Air Tanker was a commercial aircraft, the DC-10, that was repurposed to aerial firefighting. And so I think there's a real role for industry to come in and, again, invest a little and also provide their expertise. I think one of the keys, and for those programs I mentioned on that slide where we've had success, the real key to that success was to start small, do something good, and then make sure that goodness was advertised, and pretty soon, literally, people are beating a path to your door asking for that capability. The Very Large Air Tanker, nobody wanted until they saw what it could do, and then people were getting into heated arguments over who could get that tanker first. So I think that's the way to do it. I think that's also the failing, is that many times agencies or companies, want to do everything all at once. And it really needs to be an iterative process, and it needs to be fully collaborative with the agency. That was another thing we did. We brought in agency personnel from the very beginning, showed them what we're doing, got their inputs, and industry and the agencies both learned from that experience, and it was much better and quicker solution.
Thanks.
Welcome.
Well, Mark, thank you so much for your time, your insights. I learned a ton. I mean, I always learn from these seminars, but I learned a ton from you today and a lot for me to think about. And you gave us some hope. So I really appreciate that. So again, if you're listening to the recording, you saw the contact information, please reach out to Mark. If you have any questions about the seminar series or somehow need to contact Mark, if that doesn't work, let me know. For the few that are left here a little bit late, we have PG&E coming with us next week. So we'll be shifting gears. A very generous soul, maybe, sort of scary if you're a PG&E person to come here, but if you want to hear a little bit about PG&E's perspective, that's our speaker for next week, Andy Branches from the Risk Management System Center there. So thank you again, Mark. Thank you for everyone's attention, and we'll hopefully see you again soon. Take care.
Yeah. Bye.